right, here's the third of a problem of this variety. This involves, again, the similar notion of finding a value of b in our problem, but now this is involving our exponential models that we've been working with. And so we're given that the population of a certain species in an area is given by, and here's our equation, P of t is equal to, excuse me, b times 2.5 raised to the 2 times t power. And it says if the population, the value of P of t, the population at time t equals 2 is 156,250, what is the value for b? All right? So again, I think the notion is we need to set up the circumstance that we have and then use that to back solve for the value of b, which will cause that circumstance to occur. All right? So we're given that the population at time t equals 2, so we know when t equals 2, that is to say when you take t equals 2 and substitute it into that expression, that gives the value. We're told what the population is. The population is given by that expression evaluated at any particular time t. So we're given that when you substitute t equals 2 into that, that value must equal 156,250. So we know when t equals 2, the population is 156,250. Establish the condition to be met, and then back solve to find what value causes that to occur. Again, we're asked to find what is the value for b, so let me go ahead and write that out here. That's what we're looking for, find the value of b equals. Now we know when t equals 2, so that is to say substitute t equal 2. So we know that b times 2.5 raised to the 2 times 2 power is equal to this 156,250. We can compute this expression. We know that b times, and I've computed that. What do I have that to be? I have 2.5 raised to the power, I'm just going to say that's 4, is 39, so b times 39.0625, that must equal to 156,250. Well, that's not brutally challenging algebra. Divide both sides of that equation by 39.0625. And so it's 156 divided by 156,250 divide by this value. And I'm running out of space, so I'm going to write that here. Well, here, I'll just write it here. So what does that imply? That implies that I'm going to take 156,250 divide by the previous answer, and that's 4,000. If you rounded this, you're going to get a different result. Don't round this until you get to the very last bit, and it turns out this works out to be exactly 4,000, at least to this degree of accuracy. So again, that's straightforward. If you sort of keep your wits about you as to what each piece represents, you should be able to work your way through that.